This one, if you increase the voltage across the resistor? Yeah. So if you increase the voltage across the resistor, what happens to the resistance? So this comes up in a couple of places. I know that V is equal to IR. So you might say that, well, if I increase the voltage, that should increase the resistance. But that's not true. If I increase the voltage, the current changes. I mean, think about those resistors that you use in lab. If you change the voltage or you change the current, it doesn't affect the resistance. Like the resistance is always a constant value. For a given device, the resistance will remain constant. So I know the equation, it sort of looks like if you change the voltage, it changes the resistance, but physically that's just not true, that the resistance is always the same. Same is true for the capacitors, right? That even if you change V, which will change Q, like, well, let me write the equation, that Q is equal to C times V. And I ask, you know, what happens if I increase the voltage? It doesn't affect the capacitance. The capacitance remains the same, but the charge increases. Okay, so the resistance and the capacitance will always remain constant unless you're changing the dimensions of the resistor or the capacitor. Then that will change the resistance or the capacitance. Okay. What else? That answer your question? Yeah. What else we got, y'all? Yeah, 16 on 2017. Okay, so R2 has a voltage of 8 volts. Shouldn't be surprised. You will have one like this where I give you a voltage of some embedded device, a resistor or a capacitor, and then you have to determine something about the other voltages. But in this case, R2 has a voltage of 8 volts. The best way to look at this is to think about the equivalent circuit, where I have this resistor is going to have 8 volts. And then what is the resistance of that resistor? That is, what is the equivalent of this whole thing right here? Well, that's a 6, 3, and a 2 in parallel. What is that? That's 1, right? 1, 6 plus 2, 6 plus 3, 6. That's 6, 6. So yeah, so that's equal to 1. So I have a 4 ohm resistor and a 1 ohm resistor. And the 1 ohm resistor has 8 volts across it. You with me on this? Because if this resistor, the 6 ohm, has 8 volts, that means the equivalent resistor also has 8 volts. Is that clear, Trish, so far? And then this 4 ohm resistor now, well, gosh, what is the voltage across the 4 ohm resistor? It's a bigger resistor, so it has a bigger voltage. Remember, bigger resistors carry bigger voltages. Bigger capacitors carry smaller voltages, but bigger resistors carry bigger voltages. And this is going to carry a bigger voltage by a factor of 4 because the resistance is 4 times as big. So that means that the voltage will be 32 volts. So at 32 volts, that means that this voltage will be 32 plus 8, which is equal to 40. So A is the right answer. I'm pretty sure there's a very similar question to this, actually. I remember working through one that was a lot like this. And then also, as I said, this combination, I just noticed it. I didn't do this on purpose, but the 6, 3, 2 combination comes up two or more times. So just make sure you understand the 6, 3, and 2 should be 1 ohm. Or if it's capacitors in series, that would be 1 microfarad. Okay, good question. Comes up on the exam. I think actually that type of question is more than once it comes up. Trish, that answers your question. Good question. What else? Yeah. Yeah, anyway. The first one on spring 23, of course. Yeah, even if I've done them before, I can do them again here. Sometimes it takes me lots of times to really figure something out. Spring 23, your free response is a good indication. That was this one, right? Let me just delete all this. Bless you. This one, right? It is this one we're looking at? Okay. That's right. Oh, you want the first one? Okay. Oh gosh. Okay. Hold on. Let me ugh. The hard part on these is redrawing the circuits. I mean, working out the circuits is hard too, but redrawing the circuits can be difficult into some form that is, you know, easier to read. Gosh. But what you want to look for is you want to look for the junctions. So I start on the big side of the battery, and I come to this capacitor. That's my first capacitor. It's going to be in series. And then I come to a junction here. However, notice that this junction, and this junction can all be collapsed down to a single point. And the reason for that is that there are no capacitors in between these points. So anytime you see that, and you will see something like that, for sure. Anytime you see something like this, I can collapse it all down to a single point. This part right here. So that all collapses down to a single point. All this collapses down to a single junction. So drawing my capacitors, I have, that's the 2 microfarad, and then I break into 3 parts where I have a 2, 3 nines, and a 1. And then also a 1 microfarad here. And then that all comes back together in a junction right here, which I can collapse that all down to a point too. Y'all follow me what I'm saying? That if I have these points, these 3 individual points, they can collapse down to an individual point right here because there are no capacitors in between those points. I can continue on. I get a third parallel branch that has the 2 2s, the 1 and the 1. And then I go back to my power supply. So it looks like that. So I have 2 microfarads, 2 999, and then 1 microfarad, and then 2 2s, 1 microfarad, and 1 microfarad. Really recommend that you draw these out, especially if you make a mistake early on and then you propagate it through. If you draw the individual circuits, it'll be able to help me to track through your mistake. But if you don't do that, I won't be able to see your mistake and I won't know what you did. The next step, I want to find some equivalents here. So this stays at 2. I'm going to take the 3 9s and the 2 2s that are in series and replace them with their equivalent. 9, 9, and 9 in series. What is that? 1 over 3 ninths. That's 9 over 3. So that's 3 microfarads right there. And then 2 microfarads and 1 microfarad. And then the 2 and 2 in series is just 1 microfarad. 1 and 1. So that's 1 microfarad, 1 microfarad. And then I can do those 2, 3, and 1. That's 6 and 3. So I'm left with a 2, a 6, and a 3, all in series. 2 microfarads, 6 microfarads, 3 microfarads. And then finally, I can find the equivalent, which is just 1 microfarad. The 2, 6, and 3 in series is just 1 microfarad, and I have 12 volts across the battery. Okay? So now I can remember my rules and I can start stepping back. So once I get this, I recommend you take it all the way through to the end. I know that this has a charge of 12 microcoulombs. Let me go to a different color. If you want to, by the way, use multiple pens, you can if that helps you. This has 12 microcoulombs in it. Because that has 12 microcoulombs, this also has 12 microcoulombs, this has 12 microcoulombs, and this has 12 microcoulombs. So they all have the same charge, and I know that V is equal to Q divided by C. So if they all have 12, that means 12 divided by 2 is 6, 12 divided by 6 is 2, and 12 divided by 3 is 4. 6, 2, and 4 volts. I can just double check that. I know that 6 plus 2 plus 4 is equal to 12. And then I also recognize that the smaller capacitor has the bigger voltage, which makes sense. And then I can see that this is 3 times as small as this, but this voltage is 3 times as big as that. So the ratios hold up too, and they all add up to equal to 12. I can carry some of this back. I have 6 volts here. I know these are in parallel, so they'll have 2 volts, 2 volts, and 2 volts. And these likewise are in parallel, so I have 4 volts, 4 volts, and 4 volts. Just stepping back, they're in parallel, so they all have the same voltage. I can go back again. This is just carrying that back. This is 2 volts and 2 volts. We'll come back to those 9s. This is 4 volts and 4 volts. With the 9s, I have 3 identical capacitors. All together, they have 2 volts. So that means that each of them is going to have, well, 1/3 of 2 volts because they're all identical. That would be 2/3 volts on each of these. And then similarly, I had 4 volts across those 2 microfarad or 4 volts spread across those 2. So this is going to be 2 volts and 2 volts, only because they're identical. Okay? If they weren't identical, I'd have to find the amount of charge that was on this, and then say these have the same charges, and then calculate the voltages, like I did in the beginning. And then we can go back, although at this point, we might be able to answer all the questions. Let's see, the voltage on C1, that's this capacitor, that's 6 volts. The voltage on C6, where's C6? That's that 1 microfarad capacitor, that's right here. That's 2 volts. And then the charge on C7, C7 is this capacitor. To find the charge, that's C times V, that's 4 microcoulombs. 6, 2, and 4. Okay? Draw those pictures. It'll help you. I mean, those 3 questions, it probably took us, what, 4 or 5 minutes? I mean, I knew what I was doing. It probably took about 4 minutes to do that. So that's probably about right, 3 or 4 minutes, but you really want to draw the pictures. You should have time, right? It seems like nobody's struggling for time in the exam, but take the time to draw the pictures. Right? Draw the pictures? All right, what else? Yeah, Leah? In the multiple choice? Okay. What I intended for this question was like we did in lab, that I is equal to V over R. That is, if I plot I versus V, that 1 over R is equivalent to the slope. You all see what I did there? We've done that in lab a bunch of times. So the slope is equivalent to 1 over R. The slope here is 5 over 20. That's the rise divided by the run. So the slope equals 5 over 20, which is equal to 1 over R. Solve that for R. R is equal to 4 ohms. That's what I intended. Usually what students do on these, which I've been given these the past few years, like usually what students do is they just say I is equal to V over R, and they'll just take a couple points, straight lines, so all the points are the same. Like 2.5 divided by 10 would be, no, I'm sorry, V over R, 10 divided by 2.5 would be 4, because the voltage would be 10, the current would be 2.5, or 20 divided by 5 would be the resistance. You see what I'm saying there? Like they would just pick 2 points and they would say, well, at this point, V is equal to 10. It's right there. And I is equal to 2.5. And so R is equal to V over I. That's 2.5 over 10 over 2.5, which is 4. Either one of those techniques is correct. I like the first technique because it's, using the slope of the graph and it includes all the data points. But since it's a line that fits all the data perfectly, like either is correct. Is that clear? That question has been on the past 3 or 4 years exams, so probably going to see it tomorrow too. I don't remember, but probably. I think Nelson has his hand up. 2020, number 24. 2024, number 20. Which one is this one? I don't remember. Sure. I mean, the way you do this is I imagine that I have a battery that's 12 volts. Here's my R. My other R is 4 ohms, and I have a current equal to 2 amps. So I'd say that 12 minus 2R, excuse me, little r, minus 4 times 2 is equal to 0. So that's R is equal to, was it 2 amps or 2 ohms? Was it 2? Is that the right answer, 2? Yeah, B. You'll see what I did there? I don't remember. Like, is it on the exam? Maybe. I don't remember. Sorry. I'm not trying to be, what, coy? I just don't know. Emily? Okay.
22, number 7. It's similar to what Jack, but I think you have to make it in a different way. I was wanting to know if you just set 1 over R equals the slope method.
Yeah, this is the same.
You just set it equal to 1 over R.
Yeah, you can set the slope equal to 1 over R. Or, like I said, students usually think this is easier, is they could just pick a point on this graph and say that, oh, where are the numbers? Oh, no, you can't do that on this one. Oh, boy.
That's what I was thinking. You just put 1 over R equals to
Yeah, you would just say 1 over R is equal to the slope, which is 2. So R is equal to 0.5. Oh, that was a good idea, getting rid of the numbers, because then you can't do that. I'll just give you the slope.
I think that's, no. I mean, I have it memorized, but.
We don't memorize it. It's just that, V is equal to IR.
Yeah,
And so if, yeah. And so if I know that here I'm plotting I versus V, and so if I put that in the form of a line, then 1 over R is the coefficient to V, so that is equivalent to the slope. See, I wrote it like this because I have I on the y-axis and V on the x-axis. So I write this, express this equation in this form, and then that shows me the coefficient of the x variable, which is the slope. Yeah, that's a good idea. Just give the slope in the question. That was my idea. Yes. All right. I don't even remember what I did. I might have did something like that. All right. Other questions, Joe? (2017) is that this one? Is this 2017? No. Oh no, 2017. Oh, yeah, okay, so, I is equal to V over R. That's what you do first. Define the current, that's 32 over 2, so that's 16 amps. And then I want to know Q. Q is equal to I times T. So that's equal to 16 times 10, or 160 coulombs. And then I want to know how many electrons that makes up. Well, I know the fundamental unit of charge is 1.6 times 10 to the minus 19 coulombs. And so I just say 160 divided by 1.6 times 10 to the minus 19. Oh, yeah, so it has to be E. 1 times 10 to the 21. That's electrons. So I'm pretty sure you'll have a question like this, except for this last part. Like I'll just ask, what charge is it? Which is sort of what you're probably more used to. But this threw you because I was asking for the number of electrons. But you just take the charge, which is 160 coulombs, and then divide by the charge per electron, but not tomorrow. Okay? Not today, not tomorrow. Is that good? Did I do that wrong, Lexi? Okay. All right. Other questions? Y'all feel pretty prepared? Pretty well prepared? Me? Yeah. Okay. Well, if no questions, we'll stop. We're good? That was short. All right, guys.